um, uh, terminologies and all. And coming to the today's session, so just I'll try to give some more insights related to Hadoop architecture and some other commands, right? So before going to launch, okay, let me give you the objectives of the session. Uh, Initially, we'll see Hadoop services, but let me give you one more time. So just let us as a recap kind of thing. And second thing is we are having data explore. So let me show you how much data got explored in the recent trends, and as well as type of the data like structured versus unstructured, and how it is influencing the big data technologies. And once this is over, just let me introduce you the concept of distributed file system, and what is the benefit of that distributed file system and all. And most required topic is Hadoop internals. Okay, Hadoop internals, and of course some of the commands related to Hadoop distributed file system. Okay, so this is the flow we'll follow in the today's session. We'll try to cover these aspects. And if any aspect is left over, then we'll take that as a next session topic, right? Okay. And friends, we have started the discussion in the earlier session. Of course, I have given some insights related to the local file system and as well as Hadoop distributed file system. There we have seen the creation of the data or a file creation, and as well as in Hadoop distributed file system, some sort of import export aspect we have seen. Okay, so and that particular in that cluster also we observed some kind of components, Cloudera manager and web shell and few login portal, and thereafter Jupyter Hub. Periodically, we'll use these particular things. Of course, the Cloudera manager gives us the complete set of the tools we have configured in the cluster. And this web shell, of course, command orientation. Maybe if I want to interact with the Hadoop distributed file system, or if I want to start Hive or Piglatin, all these kind of things. Even the Spark job submission also we'll see in this web shell. And the third one, friends, actually today I'll show you how to load the data and how we are going to perform some kind of activity with respect to the graphical user interface of the Hadoop. This Hue login portal is GUI of Hadoop. Basically, in the earlier the 1.x and all, we completely dependent on the command orientation. But of course, users, always certain users demands for some more activities. So they have embedded some kind of the portal. So with respect to that particular portal, the user can upload the data and manage the appropriate file information according to the requirement. And this Jupyter Hub, guys, basically this is so as to implement the PySpark, and this is also we are going to see, and Scala also, Python we have seen, so that these two aspects can be observed with respect to Jupyter Hub. So in a typical environment, guys, suppose if I'm referencing any Python Jupyter notebook. So this particular thing is having, of course, Python relevant packages. Like if you are surfing any blog or something, then definitely these packages you would have seen. So NumPy, Pandas and all. So those packages are available with a typical Python Jupyter notebook. But in our Jupyter Hub, so this is the combination of basically Hadoop distributed file system we are using. On top of that, okay, we are running some PySpark jobs. Okay, some kind of the implementation. So this particular thing, that is the reason there is a difference between Jupyter Notebook and as well as the Jupyter Hub. Jupyter Notebook basically allows certain packages and functionalities related to the Python programming, whereas our Jupyter Hub is something different, where on top of this Hadoop distributed file system, we can execute the Spark jobs. Okay, so that however we are going to see while discussing the Spark and little Scala orientation. Okay, so this is the understanding of all the four components. And in the services, if you are referencing the Hadoop services, just you can see some different services trends. And as I said, we are having certain versions, but we are now dealing with 1.x. And slowly I will introduce you with the different versions. Okay. So because not much distinction, but just we need to understand this architecture. Architecture wise, same kind of the aspects in all the versions, but only the naming conventions, some flow of the data will be different. Okay, so just at the in the initial understanding of the architecture, first we have to settle down with the components and how the initial establishment has taken place, and then on top of that we can understand the advancements in Hadoop. Okay, and coming to the services, there we have seen set of the services, 5 services we're having, name node, data node, and secondary name node. And thereafter we have seen a job tracker and task tracker. So these are all 5 services or daemons available in Hadoop, and each and every daemon is having its own functionality, which is a master and which belongs to storage layer, and of course metadata, which maintains the metadata of the cluster. Data node belongs to the slave. This is also belongs to the storage layer, and it maintains the actual data. Similarly, if I'm having the secondary name node, it belongs to master. It is also belongs to the storage. It gives the backup copy. Okay, so as a backup of the name node, you can manage the secondary name. And coming to the job tracker, so this particular job tracker is belonging to the master, of course. It is not belonging to the storage, but it belongs to the MapReduce. Probably tomorrow we'll see MapReduce, which is very interesting, guys. And the many functionalities are there, friends, related to job tracker, like job scheduling and as well as a job split, monitoring of the job, everything. Okay. And coming to the task tracker, of course, belongs to the slave. It is belonging to the category of the MapReduce, and actual execution of the job. Actual job execution is taking place in terms of task tracker. Okay, at a glance, just we are seeing this thing. Okay, now as a part of our discussion, uh, just we try to understand how the data is uh, populated by starting from the industry and up to the individual users. Let me pick up some images for you so that I can give some more insights of that. So if you observe the kind of the narration, 1 minute, please, I'll pick up that. Okay, so which is trying to give the kind of the information, where how we are getting the data and how much information is generated. in the applications. Okay, no matter whether you are using um, some kind of e-commerce or whatever the way we are utilizing the applications. But the data volume growth is enormous, especially if you see a bump in this 2013-14. Until that is very limited kind of thing. But 14 onwards, it is rising like anything. Okay. So here, global data volume in zettabytes. Okay. So and here you can observe the hierarchy. We always know the gigabytes of the data. Even in our machines also, we use to store that GBs of the data. And terabytes. Those GBs forms terabyte, and those terabytes form petabytes, and those million terabytes form exabytes, and such kind of billion terabytes form the zettabytes. Now we're in the era of zettabytes, so we are far ahead than our GB's data. Okay, so this particular growth is not only from the industry side, friends. Maybe in the Facebook example we have seen, in the span of the 20 minutes of the time, how the people are generating and how that particular data is used by the researchers. Okay, so for the log file handling or for the processing of the data, all these conventions are common. Okay, apart from that, if you observe the another convention, like let me ask you this question. You can use the chat window, friends. Structured versus unstructured. Okay, how do you observe this thing? Because no matter whether you are using the data engineering perception or data science context, or of course big data context, there is always we have to define the data. Okay, so in case of the relational models, simple, the data is available in the tables and we are having a typical table storage and all the things. But whereas at the moment I am talking about the structured and as well as the unstructured kind of the data, then there should be some kind of the convention. Okay, so to observe that particular convention, so let me pick up one more diagram where as per the trends of the market only will implement or will launch the projects, friends. Okay, because it's not our wish. Maybe some community of the user, if they wish means it's not going to happen. So of course, some people who are having power and in case of the political agendas and all, it may be possible. But in technology perspective, okay, if some people wishes also that may not succeed. Especially if you refer, actually, if I'm talking about the Spark initially launched with Mesos. Okay, but people started using Spark on top of Yarn actually. Okay, Spark was not designed to run on top of Yarn, but their native is Mesos, and of course, entire Spark was written on Scala. But the surprise, now Spark Python implementation running on top of Yarn is a best combo. See, the developers' mindset is they designed the Spark on Mesos cluster, and they have used everything. They designed each and every aspect in Scala only, and their thought process is people can make use of Scala to run the jobs, to submit the job to Mesos with the help of the Spark engine. That is the idea. But what the shape it has taken is like this. That time actually Hadoop is popular, and of course, Yarn is cluster management of the Hadoop. Hadoop. There are certain pitfalls in Hadoop we are going to talk, and so as to leverage, and people who are using Yarn felt that okay, Spark is one more engine. Why can't we make use of the Spark on top of the Yarn? At that time, Python is budding actually 2015, budding in the sense as the advent of this machine learning and data science made this Python as a giant actually. Okay, So it's a long back. The history of Python is pretty old, but only the thing is now it is again becoming young. So that is the perspective, guys. That's what I am talking about. Because the people may be designing their particular based on their research and their mindset, they may be releasing certain aspects. But market and the members, the appropriate members who are very enthusiastic and very interested in the new technology learning, they give the shape, friends, actually. So obviously, the industry also follows the same. So in that case, the advent of the Spark and all these things, now you observe, okay, all these usage of the Hadoop and ARN kind of thing on along with the Spark, okay, rather than using Mesos and Scala. And still 98% of the development in Spark is with Python orientation. Only, of course, 1.2 or something related to Java, and remaining 0.8 or something is Scala. It's not a pity, actually. It's a fact. Okay, though Scala is used to design the entire Spark, but the story is different, guys. It doesn't mean that I have to use Scala to run the Spark. No way. Okay, as per my wish, because that is the advantage of the flexibility. So people love to learn Python, and of course, some people still have their own development skill in CPP or Java or whichever. That is absolutely fine, no doubt about that. But only the thing is that the road which is leading to the implementation is dynamic, actually. Okay, then their calculations and expectations won't work, guys. This is the best example. Okay, so Python developers actually, while release of this Spark model in 2012, they felt that okay, this Spark might be useful for us in terms of data science or machine learning kind of the things. So they asked the designers of the Spark, can you release a plugin or can you integrate? Can you provide integration of Python and Spark, PySpark orientation? So likewise, it has emerged, friends. Actually, now it has taken entire aspects, and now the contribution of the PySpark projects is heavy compared with Scala, and Java is separate fan base is there. Okay, but here, especially in the landscape of machine learning or big data kind of thing, and one thing, one stronger point is since this JVM, the entire Hadoop ecosystem tools are executed on top of this JVM. No matter whether I'm using Scala, Spark, or PySpark, underlying thing is JVM must be there. So that is Java is evergreen, guys, but only not indirectly or directly we are making use of that thing. But in the front end orientation, in the visibility kind of thing, Python is really far ahead compared with other technologies. That is the point we have to observe, especially in this context, big data and data science or data engineering, if you are talking about this stack, actually. Now, try to understand this diagram, guys, and please give your insights. I will take a pause here. So just have a look on this and try to give your observations in this. Okay. So one, just if you observe this thing, yes. Have a look on that. I have pasted in the chat window also. Yeah, some of the charts I have seen, no problem. Just I'll come back and I'll have a look on that. So now you can easily observe, friends, at the outset. Suppose if I am talking about this particular diagram, um, so how the flow, okay, up to 2010 we have taken, because thereafter no need. You can connect this diagram with this thing, actually. From 2010 onwards, we're having this thing. And definitely that is the unstructured data. Okay. So now you see, have a look on this. One simple point is compared with structured data, unstructured data usage is more. Okay. And moreover, to simplify the understanding, of course, structured data, which is having some typical architecture while storing and as well as the processing of the data. Example, RDBMS or transaction data. And coming to the next one, the semi-structured orientation, email, XML, all these kind of the data belongs to the semi-structured, unstructured data. Okay, your log file processing and human readable text, videos, okay, images, audio file, all these things. Probably, you know, guys, deep learning and some sort of machine learning algorithms are definitely useful so as to process these kind of the data items. Okay, so the base point we are making here is, guys, the data growth is enormous. Like this, it is growing, and of course, one more important insight is compared with the structured data, unstructured data is booming up. Okay, in that case, the challenge is, as I said earlier, first is the storage, next is the processing. These two are the main challenges faced by the companies because it's not due to the Hadoop, it's due to the heavy data availability in the machines. Okay, because data is populating. If you are using the data, then you can catch hold of the business. If you are ignoring the data, then you are far behind the race. Okay, so either you want to take or leave. Only two options were left with the companies. Then these storage models and all came into the picture. In that particular case, guys, let me introduce you one important aspect, which is a foundation stone for Hadoop distributed file system, which is DFS actually. Okay, distributed file system. Okay, so generally, guys, in the Hadoop orientation, we have seen two important aspects. Hadoop is a combination of the HDFS and MapReduce, and this is nothing but the storage, and that too, the storage is the distribution actually, is a distributed storage, friends. Whereas if I'm talking about the MapReduce orientation, is a parallel processing. As I said, is a simple programming model and which is allowing us the concept of the parallel processing. And the entire Hadoop follows the framework kind of the activity. Okay, and we can realize, friends, and today I will introduce some of the commands where with that you can see how we are making use of this framework. And especially while starting with MapReduce 1, MapReduce 2 or AR, then you can easily see that how this particular framework really helping us. Okay, so these points just to observe. Now, coming to the distributed environment, pretty simple, friend. This is assume that I'm having a machine with certain capacity. My activity is to perform the reading operation of 1 TB of the data. Assume that with certain configuration, it took 45 minutes so as to complete the process of the reading. Whereas if I want to establish such kind of the same configuration machine with the Y configuration and all the machines, okay, just I'm launching 10 more machines, 9 more machines along with the original machine. All are having the same kind of the configuration. Now, the same 1 TB of the data I want to read or I want to process, then obviously this 45 by 10 machines, which is 4.5 minutes. See, such a simple narration. So distributed file system, or to understand the distributed orientation, just launching the number of machines. Okay, launching number of machines and all those kind of the machines are helping us to reduce the time factor related to the corresponding whatever the information we are talking about. Now, in the same genre, so I want to give you some kind of definition, okay, related to Hadoop, because so far we have seen a simple definition. Like, you know, guys, Hadoop is a framework where which is giving the storage layer and as well as the processing layer. And according to the requirement of the user, he can perform the activities. Now, have a look on this, guys. What exactly Hadoop does is Apache Hadoop is a framework that allows for the distributed processing of the large data sets across clusters of the commodity computers using a simple programming model. Here the highlighted or bold things you can see distributed and cluster and commodity computers and then simple programming model. Simple programming model. Distributed, which is HDFS. Okay, first thing. What do you mean by cluster? We'll talk about that cluster. Okay, and commodity computers, some number of machines, cheap, I can say some cheap hardware or some kind of the computers where I can make use to establish a kind of the environment. So, and simple programming model. So this is the second one. This is the third component. My fourth component is the map reduce. And we were aware of this first and fourth because this is the storage and this is the processing logic. Now, friends, to store the data, definitely I need the systems. That is a commodity hardware. The third point, commodity hardware. And of course, after storing the data, I have to run this. I have to process this particular data on top of the cluster. You know, clusters provide the environment. Okay, as we have seen in the earlier thing, just if you observe the way we are running our cluster. So let me show you that. So if you are referencing this particular cluster orientation, friends, this particular cluster, this is nothing but the cluster actually. If you observe this kind of thing, this is the cluster. This cluster, all these Cloudera manager, okay, all these things will be there where you can make use of the convention. Okay, so just I'm making use of this thing. Okay, so as to interact and then let me copy this thing also into my password. I can able to connect. So this particular cluster giving us okay the understanding of how many tools are there. Okay, because that cluster provides one environment. Maybe if you are talking about the GCP or AWS or all those kind of the things, they provide us okay some kind of the environment where one can make use of that resources. Cluster is nothing but a resource, friends, which is a commodity of computers or which is giving us some kind of the all the possibilities or configurations. Now you see, just it is giving us the information cluster CPUs, cluster disk IO, how it is writing, network IO, HDFS IO, okay, and master node. Okay, master node means name node information about that, and data node information, how we are making use of these things and all. See, this is how we are seeing a cluster because this particular cluster provides all the resources to the user-defined programs or user-submitted jobs, and it provides a convenient environment so as to process and access the data. So if you are referencing this cluster mode, now Hadoop is such a tool, guys. Okay, it's not only just it is a framework kind of thing. It is out and out providing. If you go back and see the definition once again, is a framework that allows for the distributed processing of large data sets across cluster of commodity computers using a simple programming. So here HDFS MapReduce we are familiar, and commodity computers is a cheap hardware. Tons of the machines we are having, and all those machines are connected in the distributed fashion. Distributed, as I mentioned earlier, rather than using one machine, if I could establish some set of the machines to perform some kind of the activity. Obviously, it is reducing the time factor. That is the initial advantage or significance of our distributed file system. But it is not only the advantage, but also we are having in terms of the Hadoop, we are having this simple programming model, which is making use of this cluster so as to submit and observe the status of the jobs. So this is how you can see the Hadoop orientation, friends. Okay, and in a simple okay, maybe if you are talking about Hadoop, and while someone is asking you like what exactly the Hadoop you mean to say, then you can say that it's a open source data management with scale out storage and distributed processing. It scales horizontally to manage petabytes of the data, abstract away distributed storage and computing. Now, many things are there to understand that. Scale out architecture, scale in architecture. Okay, just you see here, guys. Scale out in the sense, adding, suppose I'm running one application and initially I'm having some 3 computers so as to perform the task. But whereas I felt that, okay, if I establish some 3 more machines, then definitely productivity is more and I can implement the task with less time and more productive. So this is what you call the scale out. Scale out architecture is nothing but attaching multiple machines to the existing environment. That is the scale out architecture. Scaling is simple. I'm having only one machine with me because I got only one machine to implement the task. But only the thing is I'm making use of my RAM extension. I'm adding RAM and I'm adding processor capacity. Okay, I'm empowering only single machine. Now, friends, there is a limitation. Just like that, I cannot add RAM infinitely. And just like that, I cannot increase the processor capacity infinitely. There is always the limitation in case of the scaling architecture, but your Hadoop is scale out architecture. Scale out in the sense there is no restriction. Number of machines I can add, keep on, I can increase this particular cluster capacity whenever there is a requirement. Now you see, let us try to understand in this way. I'm having the name node architecture with me, whereas I'm having some 3 data nodes initially. Even in our cluster also, we're having 2 master nodes and 3, 4, 5. These are the slave nodes. And of course, according to our client demands, maybe I can ask, you can extend up to 10 machines. Then it becomes, so these 2 are the master and 10, 12 node cluster actually. Now we are using 7 node cluster. Like that, you can increase according to your requirement. You can simply attach the appropriate slave nodes and you can perform your activity. Okay, so that is what you call the scale out architecture. Scale out in the sense, according to the requirement of the application, I can add more number of the machines. Now you have a look on this frame. Some of the points we need to see. Open source. Of course, directly you can download, and probably today I will be sharing how to download the Hadoop software and how we are going to install that. And of course, periodically you can install Hive, Piglet, and Flume, Scoop on top of that Hadoop. Okay, that you can practice, guys. And with data management. Data management is something like which is providing us the storage and processing of the data, access mechanisms, all those things. As I said, scale out storage, adding the number of machines. Okay, number of machines according to the requirement of the applications. And of course, distributed processing, distribution, as you know, multiple machines are sharing the work and in a way we can manage the things without any hassle. It scales horizontally. Okay, vertical scaling is different, friends. Vertically in the sense only one machine we are empowering, like as I said, in scaling architecture. But horizontal scaling is nothing but just we are keep on adding the number of machines. Okay, in this way. Okay, so this is how you can refer to manage the petabytes of the data. This point is important, guys. Abstract away distributed storage and computing. Now let me tell you this point. At the moment we are giving this statement, friends, Hadoop FS hyphen copy from local. I'm using LFS1 to HDFS1. Now see, internally many activities are there here because first this command should reach to the name node. Name node should see the corresponding data node information. And because the replication factor is 3, so this particular HDFS1 should be created in 3 locations. But without knowing all these things to the user just simply enjoy the benefits of the copying of the data from local file system to HDFS. Now you have a look on this screen, the statement. Abstract away distributed storage and computing. Computing, I will tell you guys, because now we are talking about the storage only. Our primary discussion is with HDFS. In terms of the computing, okay, guys, just we are need to talk about the MapReduce, which is of course um, solution for all the parallel kind of the problems. But just now we are in the gist of this architecture. Once that particular architecture is over, then we can come back and see the usage of the MapReduce and all. Okay. So with this, we can have a fair understanding of what exactly the Hadoop framework and in the earlier context. That's what, friends. The learning should be like this. First, according to our experience, according to our understanding, we should see the things. And once we have that particular items in our plate, then we need to have the taste of it. Like, okay, earlier we have seen that Hadoop is a combination of HDFS and MapReduce. We slowly understood that, like, okay, HDFS is a storage and especially distributed storage. MapReduce is a simple programming model, okay, with the parallel approach. Now we are extending our understanding like this. Okay, HDFS is a scale out architecture. MapReduce is nothing but parallel. That remains same because we have not yet explored more. And moreover, related to these kind of the functionality, we have seen some more technical jargon like cluster and commodity computing. So because the commodity hardware is something like which is allowing us to store the data, and that particular cluster computing or cluster which is providing as we have seen in our cluster. So just the combination of all the tools and which are allowing us to store and process the data. Basically, the cluster provides environment so as to submit your jobs or so as to monitor your job processing, all these kind of the conventions. Okay. Now, yes, you may be having some doubt. Now, what exactly the big data? Because so far we are talking about Hadoop and all those kind of the things. That is perfectly all right. But how can I define the big data? Because that is a more catchy word. And of course, I need to understand that particular word also fairly. And in what way I can see the appropriate aspect of the big data. Now, just that particular big data, I need to define in this way, guys. So have a look on this, what exactly the big data kind of thing. Just I'm bringing some kind of the definition for you. Uh, just to see, guys, what exactly big data is a phrase fundamentally used to describe massive volume of both structured and unstructured data. So that means I'm having the data where the data is available in the format of both structured and unstructured. Both the formats were there. And moreover, what is considered big data varies depending on the capabilities of the organization. As I said, so big data, there is no specific definition. Suppose if ISRO is launching some kind of the project or some kind of the rocket, they have to study. They need to store all the data and they have to monitor that particular thing. Okay, that is somewhat a different zone. Whereas if Facebook is Facebook in the context of the Facebook, we are having likes and as well as the shares, comments. That is the perspective of the Facebook. Whereas in case of the Twitter, okay, as I said earlier, we are publishing one article in probably the Spark architecture, and we want to get some kind of the feedback on that. Okay, then we need to observe the sentiment analysis. So it all depends, guys, because just now if you see the orientation and moreover in the company perspective, suppose if you are talking about the company and growth rate, annual growth rate, if I want to verify, okay, quarterly, how we are performing, half yearly, what is our share value, and yearly, how we are doing. So the perspective is different. Of course, all these scenarios definitely belongs to the big data because as we are managing all the massive volumes of both structured and unstructured data. And it doesn't mean that payroll of the employee or calculating CGP of the student never belongs to the big data problems, friends. Okay, see, only huge data is not going to define the big data problem. Big data problem is it should have some significance like this. There should be huge data and structured and unstructured, and there should be some tricky analysis on that. Okay, all these kind of things. Though we are having some gigabytes of the data, computing the CGP or payroll, they are all typical implementations, guys. They never become big data problems. Okay, have a look on that. Now, what is considered big data varies. Just I said, like ISRO and all your Facebook or Twitter, how they are managing the data set and on the capabilities of the applications that are traditionally used to process and analyze the data sets in its domain. Okay, maybe some of the medical applications or some manufacturing kind of the domains or some retail kind of the thing or e-commerce applications. Many are their friends. Okay, according to their particular requirement, they are going to utilize this particular big data. Now you tell me, you can use the chat window, big data and Hadoop. In a single liner, how we are going to define that, friends? Because both the things I have given to you, what exactly Hadoop and how we are making use of the big data kind of things. Uh, then you can come up with some kind of the single statement. I'll be waiting here, guys. And meantime, let me go through your, yeah, many are there. So I can, and meantime, you can make use of the chat window so as to understand, so as to, in a simple way, how we are making use of your how you can give someone asks you what is big data and what is Hadoop, then how do you refer that thing? Okay, I'm waiting for you guys. Just you make use of this thing and let me see how many of you are venturing this particular answer, right? Okay, Bala says structured data, Excel format, unstructured image, video, and audio. Very good. And Harish is saying structured data, something like quantitative, and data is often stored in data warehouses. Of course, perfectly. In the structured data, friends, majority of the times we are using RDBMS or ETL kind of the storage. Okay. And structured data is easy to search and analyze, of course, because there is a proper structure and identification, and it is easy for us so as to perform the uh, process and accessing of the data. But the current trend is, friends, how we are flexible with structured data in the same way. The unstructured data processing also becomes very easy, guys. Okay, becomes very easy with the tools like Flume and as well as this Spark streaming, all these kind of the conventions. Okay, that is one more advancement. And as far as if you are considering the unstructured data is a qualitative, um, qualitative, okay, and data is stored in data lakes. Unstructured data requires more work to process and understand. That is the earlier in the earlier days, friends. Actually, after the Hadoop, okay, just you can. We are having many advancements in that. Okay, Vedant says structured data is clearly defined and organized. Unstructured data is usually stored in a native format. Okay, is easy to search and analyze. On the other hand, unstructured data requires more work to process and understand. Okay, Astrolochan is saying structured storage in columnar format. Mhm. Okay, so and unstructured, not in particular order, but randomly placed images, data, etc. Okay, Srinidhi is saying structured data consists of number of value, numbers and values, whereas unstructured data consists of sensor text files. Of course, is a category of the data how we can manage. Okay, so now if you are referencing the big data in a simple zoner, friends, because I cannot wait for you because time is not there. Na? So big data is a problem actually. Okay, Hadoop is nothing but a solution. Because companies are facing the challenge of storage and processing. and they need to handle both structured and unstructured data. And of course, Hadoop is absolutely uh, performing the activity of these things. It is providing a framework which is used to store and process the data. Of course, it is okay with structured and unstructured formats, and that too on top of a cluster with the commodity hardware. Just it is going to perform some kind of the activities. So now we are connecting the dots, friends. Okay, big data is a kind of the situation where companies are facing, like and there is always a challenge to handle the unstructured data and to store heavy data, okay, which is populated starting from the individual member up to the level of the users, up to the level of the companies. Okay, all these things. Now, what we'll do is let me go to the lab part. And of course, just we'll try to perform some kind of the activities to understand data storage and all. And for that, I am going to introduce some other aspects, friends. Probably you might be knowing. This is what you call the WinSCP tool. Okay, so uh, now the application is like this, guys. Okay, now the application is like this. So Monica has given very good, very good. Very good. Okay, so let me use this thing, friends. First, let me introduce you what exactly the WinSCP orientation, and then I'll come back to your answers, friends. Thank you. Thanks for that. Okay, so I'm introducing one more concept called WinSCP, which is a tool where you can make use of the convention. Uh, like this particular WinSCP tool helps us to transfer the data from one location to another. So for that, to understand this thing, just let me show you whether I can share with you or not. Or else let me share the entire screen so that you can see. You can be with me. Okay, now you can able to see guys this WinSCP. And after launching this WinSCP, it is asking the host name, username, and password. To understand the host name, okay, just what I am doing here is just I am getting into this thing, our lab. And this particular host name is nothing but login server name. Okay, just I am fetching this information and host name I am pasting here. And your username, okay, whatever the login credentials we're having, so as to interact with our cluster. Okay, so these things, this is the access details that we need to provide. Okay, just to have a look on this. Just I am making use of this thing. And password also along with the cluster, we are having that password. So just you can make use of that thing and try to give the password also. Okay, now just to give the login. So it's very simple, friends. Like this WinSCP is a tool where you can transfer your files from one machine to another machine, especially if you are working with the distributed environment or remote access of the files. Okay, and FileZilla, you might have used that FileZilla maybe in a typical environment where if you are installing your virtual machine and you want to transmit your Windows files to your Linux or Unix operating system. So probably you would have used that FileZilla, and WinSCP is also the same kind of the file, which is most flexible version. Now here the idea is, guys, first let me introduce what I'm going to do. Just I'm logging in with my, just by establishing the connection between, I want to establish a connection between my laptop and as well as that cluster. Two panes you are seeing here. This left pane, I'm placing the cursor. Left pane is the machine. This is the local machine. My laptop, all the details are available. So if you see, so desktop, whatever the details I'm having, just I can make use of these kind of the conventions. Okay. So, but right side, if you observe, guys, if you see the big data bind one, which is nothing but our cluster. Okay, with the name given to us. And here this is showing us some kind of the local file system, friends. Okay, so now the idea is simple. I want to get some information from the local machine. Assume that I'm having some data set and this is stock market data and data set.csv, sales info, like that. I'm having some data with me. And what I want to do is I want to pick up some data from my local machine. And from that particular local machine, first I need to transfer the data into the cluster. And of course, Hadoop distributed file system cluster I am not having directly. Assume that the idea is simple. Let me give you the narration of what I am doing here. So just I am my task here is okay. Just I am having some data in my machine, my local machine. Now I want to upload some file into my cluster and that to local file system. So this is my requirement. And of course, I know that once the data is available in local file system, I know how to load the data, how to import the data into my Hadoop distributed file system. Okay, so now the typical thing here is how do I load my machine data, that is my laptop or local machine data into the cluster local file system. For that, I'm using the WinSCP. Okay, so the WinSCP here, what it is asking is just it is asking the host name, username, password. Okay, this host name, username, and password belongs to the cluster, friends, not your machine. Of course, however, you have installed your WinSCP in the machine, your machine. Of course, you want to connect. Okay, as a connector, you want to establish a kind of the communication between your local machine and as well as the cluster local file system. For that, WinSCP, what it is what it is requiring is host name, username, password. So just this particular host name, okay, provided by our cluster. So just if you see, not only this one, friends, any cluster, if you are talking about any typical cluster, all the AWS kind of thing, GCP and all definitely have these details. Okay, what is the SSH login server? From your machine, how I need to establish a kind of the communication. And thereafter, guys, here we are having a specific username and password. Maybe in our company also, some of the members are working on top of GCP, some are working on AWS, some may be working on Azure. We are having different cluster data. Okay, even some people works on Databricks. And while using the Databricks also, you may use AWS or you may use GCP or you may use Azure. The three options are there. So that username and password is pretty clear for the users who are using AWS kind of the service on top of this Databricks, they will be given some kind of the access mechanisms, but your login server remains same. Okay, and similarly, the members who are trying to access the Azure kind of the cluster on top of this Databricks orientation, they will be allocated with some username and password. So the login server is something like that. The initial point, and after getting that particular initial point, then you can make use of that username and password. So exactly the same thing we are doing in the WinSCP. So after giving your username and password, so just automatically, guys, here two panes will be displayed. Of course, the first left side pane, I can see all the details of uh, my laptop information or local machine information. And here it is your cluster local file system. Now what we're doing here is just let me open the data set and I'm having some sales info.csv, whatever the information. So just to go down, friend, because maybe here I am having some kind of the directories, so as to avoid copying to the wrong location. So just I am getting down completely down to this particular file environment, and I am making use of this drag and drop. That's all. Nothing you need to do. Sales info. Simply it has been copied. Likewise, some bigger file, maybe somewhat bigger file. So getting down, getting this thing, and just I want to show you the copying is happening like that. Okay, so this is how you can now the sales info and as well as this Apple stock. Okay, now we got it. Okay, now what we are doing is I have to check whether this particular thing is there in the local file system. For that, so just I'm opening this cluster. Okay, and again it is connecting to the web shell. Okay, it will take some time, friends. First time if I'm connecting. Okay, so it should give us some kind of the access. Okay, login. Now I am giving this username. Big data mind one. Big data lab. Now you see connected. Just you give the ls. We know that ls is a command where I want to see if I want to see the local file system files or directories. Now see applications apple stock.csv. Just now we have copied. Now sales information.csv. Just now we have copied from these two. Okay, directly you can observe. Now my aim is now I want to import this. That is the actual idea, guys. The actual idea is something where I want to pick up my data from local machine and place the data into the uh, cluster, okay, that cluster local file system. We have successfully done that with the support of this WinSCP. It's a small utility program where I can manage graphically the usage of these kind of the conventions. Okay. And now you can easily observe, friends, home, big data mind. Whenever you are seeing this slash home, observe that that is a local file system. In your path and all these things, if you are seeing um, the kind of the data, so these are all belongs to a local file system, home kind of thing. Whereas if you are referencing the user slash user, that belongs to the Hadoop. I'll show you that because in case of the WinSCP, you can clearly realize that this home slash big data mind, this is your local file system. While talking about the new login portal, I'll show you that, friends. Okay. And now the point is, how do I import this Apple stock and as well as sales info into my Hadoop? So simple, na? Hadoop fs. Okay, copy from local. Okay, the commands remain same. Copy from local application stock. You need not type everything, friend. Just you press first 2 or 3 letters and tab. Automatically it takes it. Just I am giving this. That's all. Tab I am giving it is taking. Now what I am doing here is stock one. Just type that I want to store stock one data. That's it. Now how to verify that? Hadoop fs-ls. Just automatically we can make use of the stock data. Similarly, Hadoop fs copy from local. Okay, so we're having the uh, not sales data analysis, sales info, na? Sales info.csv. This I want to store as sales one to simplify that. Okay, now you observe Hadoop fs-ls. You can make use of this sales data and as well as the stock data. So likewise, you can easily observe, friends, no matter whether it is 196 or 143130 kind of bytes. But for the both the files, Hadoop never affected. That is the main advantage, friends. One point, if you observe in the discussion of this Hadoop, see here this point, which is large data sets, which is used to process the large data sets. So, in fact, Hadoop enjoys the enjoy if you give the large data set friends rather than the smaller ones. Okay, suppose if you are giving 100 small files and you are supplying that 100 smaller files to the map reduce, and that is one scenario. Whereas if you are taking one bigger file, maybe petabytes or zettabytes, Hadoop is best suited for the huge data only, friends. Rather than 100 or thousands of the smaller files I'm having, again, compaction, again, combining all those particular things becomes very tough for Hadoop. Whereas rather if you are making use of the convention like one file, I'm having a huge file, and it is better to give that particular file to Hadoop to process. Okay, always prefer larger content or larger files when compared with the smaller files, whenever according to the situation, right? So with this, just you can observe that WinSCP is a tool where you can refer the understanding of the observation of data from the local machine, and I'm going to store that particular data into the clusters, LFS, and accordingly we can make use of the that file. Maybe I want to import the data, then I can do whatever I want. One more point here, guys. Just apart from this kind of the convention, as I said earlier, there are if you are seeing any file starting with the home slash something, that is a local file system. Okay, that is a local file system. Now, if you observe, let me clear this screen. Hmm. So just I want to narrate something. See, many times I have typed. Okay, now if you observe this thing, friends, -ls. Okay, and thereafter, now you observe, guys. So what it is saying is LSR is a command which is recursively showing us some kind of the internal files. Okay, so the elaborated kind of the thing. But earlier, only we can see this particular DE is a folder. I will show you how to create a folder and how to use that. But if I'm using a listing of the corresponding files recursively, LSR, what it does is it is showing the internal details also. It is showing the internal details. That you keep in mind. Again, I will be coming back to this particular discussion. However, we are having some session on that, like how to create a directory and how to move the files or copy the files or delete the files. Everything we'll see. Okay, but before that, let me launch this particular view login portal. So observe, guys, here we are having plenty of users here. Many users are there, but we need to work with our mentioned user. Okay, big data mind. Okay, so click on it. So these are all the files which are related to us. Okay, now if you observe, just now we have populated some of the entries just to refresh that, because sales and all not reflected earlier. Now you see sales and stock also reflected. Now you click on the sales, automatically it is giving whatever the sales information, what is the stock market values, opening, closing balance, all these things. Okay, this is one thing. Now, now the scenario is like this, friends. In the earlier scenario, what we have done, the earlier scenario is just we have taken the help of the WinSCP and we can able to load the data. So the scenario one is like this. I'm having my local machine, and with the help of the WinSCP, I can able to establish the communication of the cloud or cluster and upload the data into LFS. This we can see. We have seen now. Now the second scenario is there any usage of uploading the uploading the local machine data to our HDFS. See, it's a direct attempt, guys. Actually, This is a direct attempt. In the earlier thing, at least we are having some barrier in the sense we are not able to directly interact with the Hadoop distributed file system. But what we have done, just we have taken this WinSCP utility and we have stored that value into the local file system. But now the process is like this. Is there any usage of uploading the local machine data to our HDFS? Yes, of course. And the procedure is like this, guys. Okay, the solution is Shoe login portal. Okay, after logging into this one, just you specify your username and you can upload the data or file or whatever into Hadoop distributed file system directly. Okay, let us have a discussion on this, guys. So just what we are doing here is just I am making use of the convention. Okay, so now I want to store some data or I want to get the data from local machine to my Hadoop distributed file system. So this is the Hue login portal. So this particular portal is having many things like Hive and HDFS orientation, all these things. It is a typical model where you can handle the file system management and all these things. Okay, now you see guys here. Okay, so just if I'm placing cursor here, you can observe that the tooltip actually /user/big data mine. In the WinSCP, if you remember, we have seen /home /big data mine. Whereas in Hue login portal here, I'm seeing that /user/big data mine. So one thing is very clear, /home /user are different. If I'm talking about the /home, remember that that is a reference of the local file system path. If you are getting the /user, okay, that is a reference of the Hadoop distributed file system. Whenever while in the documentation also, if you are getting the file path like /home/client info, then make sure that that is of course local file system reference. Our team member is notifying. Whereas if the member is giving that /user/client info, then you have to see that, oh, this guy is referencing to the HDFS path. Okay, that is the main point in the distinction between the local file system and as well as the Hadoop distributed file system. So what we're doing here is just I am making use of this uploading of the file, such a simple matter. Click on that. And here, as usual, I can make use of this data set. And this time I'm taking some data set and I want to load that data. So just I'm selecting simple guys. Okay, again, I'm doing just a plus and it is allowing us directly open the information from our machine. Okay, so just you can refer this select and I'm selecting this data set open. Okay, so this upload is in progress. But just it is showing us the upload is in progress. Let us wait. Okay, but immediately it is taking prints actually from next time onwards. Suppose you see one more file if I want to access. Click on this file and now contains null open. Is that much fast? Okay, upload progress done. Now just you refresh on this case because directly you may not see. Sometimes you may not see. Just you can use the refresh. Automatically it is connecting with the cluster and it is giving that. Now you can see contains null is one file and as well as the dataset.csv just now we have uploaded. Okay, so like that some kind of the information I'm having. Now this is one option where sometimes where you can observe it directly in the Hue login portal and still you are having some confusion. Now in that case what you can do is just you go to the web shell and you can observe Hadoop fs-ls, which we can see here contains null just we have uploaded and as well as the dataset.csv. Okay, it's a double check kind of thing where once you loaded the data into your Hadoop distributed file system, so just you are making use of the verification few login portal already we have seen. Okay, so just we have seen this particular notion. Whereas if you refer this thing also manually, if I want to see, because as of now I am habituated to use the web shell and I want to confirm whether that data is really available in my Hadoop distributed file system or not. So in that case also you can do. Apart from these kind of the conventions, what exactly this View login portal is providing us is I can dynamically perform some activities, friends. Whereas if you are making use of some convention, okay, whatever the files I'm having, I can directly load that files and I can view that. And there is one option called file browser actually. Click on this. Okay, so many details I'm having. So I thought of, okay, contains null is not required now because in the current project, we are not using that particular data. Assume that so as to maintain the cluster in a better way and that to avoid the ambiguity of multiple input files. Just I thought of this is not required. So now you select that from the file browser, whatever the file you want, just you can move to the trash. Okay, automatically just it is asking yes. Okay, so just it is updating, refreshing the list. So contains null is not there. Okay, but later you realize that after the discussion, oh, unnecessarily I have deleted that. Again, I have to capture that particular file. Don't worry, guys. Just go back to the trash. Okay, contains null is there now. It's just like recycle bin restore. Just to go back and restore. Just it is asking. That's it. Again, it is going to reflect that contains null. Okay, so and now if I want to make the deletions permanently, double checked and I confirmed that this particular file is no longer required. So just I'm moving to the trash and even I don't want that file in the trash also. So go to the trash and just to click on this and empty trash, delete all. Okay, that's all. It's a permanent deletion, guys. See, all these things we are doing in HDFS, guys. Please remember that. In HDFS directly we are doing. Okay, that's what I said. Maybe I cannot move a file and place in the local file system, but directly I can eliminate or delete the file in Hadoop distributed file system. Okay, so now if I want to double check whether that contains null is there in the above list, I can see the null contains null.csv. But at the moment I'm giving this Hadoop fs underscore -ls, obviously this file won't be there now. Latest directory structure I can see the information of the files and all. So like this, one can easily perform the activities with the WinSCP and why I am showing these two conventions, friends. Uh, it is a typical access matrix mechanism because maybe in your project you may not always have everything, always access on everything because maybe we may deal with some sensitive client and we should not reveal the identity of the client or sometimes the members are not having all the members may not have the access of all the data items. In that particular case, you will be given the provision of loading the files from your machine to the local file system or something like that. In that case, the best possible way is usage of the WinSCP. Okay, whereas if you are allowed to load the data into Hadoop distributed file system and you don't want to make use of the commands, maybe the people are not having the background of the Linux or any command orientation or scripting, they probably assign with the View login portal usage. So from that directly the member can access um, the GUI interface and he can simply specify the addition of the corresponding file, the upload. Make sure that you are in the current user notion because many users were there here. See, tons of users are there. As I said, it's a distributed cluster. Okay, many users were given and all the corresponding members were working on it. So in our case, just I'm making use of our cluster. Okay, so based on that cluster selection and user, we have to select. because this particular cluster, as I said, an entry point. And after entering into the cluster, you have to give your username and password so as to access your data. Okay, that is the understanding. That is the understanding. And likewise, you can recheck and you can perform the activities of storage both in WinSCP and as well as other kind of the things. Okay. Now, before taking the break, just I want to introduce some other discussion. Okay, so that is let me introduce the aspects of Hadoop architecture components, because that is probably the most important topic, guys, and which follows the reading and writing. Because so far we are doing some copy from local, copy to local, and move from local. All these things we have done. And but before performing any kind of activities, especially we are having some other replication factor changing and deletion of the file in the HDFS through command mode I'm talking. All to understand all these things, definitely we have to see in what way the appropriate cluster or appropriate Hadoop is maintaining the architectural aspects. Okay, so for that, just let me get to some kind of inputs, and this particular input is completely depending on the usage of distributed file system and as well as the other components, friends. Okay, so just if you are referencing these daemons kind of thing, so let me give you this narration, okay, which is very, very important, guys. Uh, the first point is how I am making use of the Hadoop services. This is the first important thing. And next important thing is how I am making use of the architectural aspects. So the architecture wise, guys, just we need to understand in what way the reading and writing operations are performed. Okay, these two we'll try to understand before the break. So just have a look on these two things. Okay, now. So I'm taking a pause here, friends. And if you're having any doubt so far, please ask me. Let me see any doubts are there other than the contributions. No, all our contributions only. Thank you very much. Thank you. Very good. Okay. Now, meantime, you can post your doubts also, guys. Okay. Let me, please, I need your utmost attention, guys, here. So far, whatever the demons we have talked, we are trying to consolidate all these things in a better way. Okay, now you observe the point here. In what way we are trying to see this orientation. Okay, now see this, guys. We pretty know that uh, we know that master, in the master I'm having name node, secondary name node, job tracker, and of course in the slave I'm having the data node, task tracker. This is pretty known. This is not a new aspect for us, but we are very much clear about that. Now the point is how these particular things are communicating. Okay, now one point gets here. If you observe the first scenario, name node, job tracker can be on the same machine. Name node, job tracker can be on the same machine. The best example is, suppose if I am giving you the installation procedure so as to install Hadoop on your local machine or on your machine. This is the best example for configuring name node job tracker on the same machine. Not only that, guys, your master and slave also on the same machine. So that means it's a single node cluster, and that particular single node cluster managing the name node, job tracker, task tracker, secondary name node, data node, all these things in your machine. Of course, that is a possibility. Okay, there is a possibility of clubbing all these things because we are having only one machine with us and we want to perform some kind of the activities. So of course there is a single node kind of the cluster. There is no distribution. Just within your machine, you are virtually managing all these kind of the things. That possibility is there. But now we have seen some cluster. There are 7 nodes actually. Ours is 7 node cluster where 2 nodes are dedicated for master. 5 nodes were dedicated for slaves. Okay, there is no question of combining master and slave in the cluster we are talking about. In our lab, whatever we are seeing, okay, there is a separation between master and slave. That is clear. So in the first attempt, what we are seeing here is your name node and job tracker can be on a single machine or else they can be separated. Okay, actually this particular aspect, all these convention, whatever I'm talking about, this and this combination is our cluster. In a typical cluster, maybe in AWS or whichever you are making use of your Cloudera distribution. And by the way, friends, Cloudera, Hortonworks are same. They are working together as a common thing. And apart from these things, let me introduce the various Hadoop distributions. Various Hadoop distributions. Pivotal, Microsoft, IBM, and Cloudera, Hortonworks. But Spain, they're having, okay, they also have Spain. Now TCS is maintaining their own cloud. I mean, their own big data Hadoop management. See, these are all companies, guys. Pivotal Software, Microsoft, IBM, Cloudera, Hortonworks, WebSphere, TCS. All these members are having their own setup. Like, this is something like this, guys. Dell is there, HP, HCL. Like that machines are there, no? Different computer machines are there. Underlying hardware is same. Motherboard they will take somewhere and processor from Asus and they assemble and they make their brand. Similarly, your Apache Hadoop is common. Only the thing is, these companies are branding them. I mean, they are putting as a package and they are making it. Like you see here, now as I'm talking about our cluster, it is given by Cloudera actually. So that's what you can easily observe that our lab. So this particular thing is something like the Cloudera manager. Okay, so like you can easily see this. Okay, Cloudera. Likewise, they are having their own setup so as to configure the appropriate tools. The tools in the sense, see, many tools are there. Now. It is simply logging out. So because the connection and within the Cloudera manager, whatever the tools I'm having, those tools remain same, guys. Okay, Flume remains same, Scoop, Spark, and as well as the Big Latin, HBase, Hive. Okay, whatever the tools we are talking about, these tools are not going to change anymore, guys. Only the thing is the branding. Okay, rather than using the Cloudera manager, they may use some kind of Pivotal or they may use some kind of IBM. Okay, so likewise, nowadays all people are putting ahead, putting hands ahead on these kind of Hadoop orientation, so as to store that. But ultimately, they should dependent on these tools only, guys. There is no separate HDFS, there is no separate MapReduce, there is no separate Spark for those guys. That is the advantage actually. The main reason why we are behind the open source technology is even you are using AWS or GCP or Azure or Pivotal or Cloudera or Hortonworks, no matter if you are learning the Hadoop commands and if you are happy to use your view login portal and if you know how to handle the Hive tables and you know how to submit your Spark jobs, then you are done. No matter where you need not go and again reinvent the wheel in case of TCS or IBM or some other. Though they are having their own setup on Hadoop or big data tools, it's absolutely clear. Okay, these tools remain same. All I'm showing here in all these kind of the tools. So these tools remain same, and there is no specification on that. Okay, there is no distinction on that. So these are all common tools nowadays, all according to their requirement, the people are specifying. Okay, so just I have pasted that. Right. So this is the understanding, guys. Nothing else, right? Okay. Now, coming back to our discussion. So, just if you are making use of these kind of the convention, that is the various tools and various companies are there so as to promote their own way of Hadoop. Now, so here we already seen that only in a single machine, I want to configure everything. That is perfectly all right. Maybe if you are going to install Hadoop in your machine, okay, probably I will explain the process and I will give you the appropriate demonstration, friends. And then now if you see the cluster, whichever the cluster I'm talking, Cloudera, Hortonworks or whichever, there are separate daemons. Especially in our case, we are using the 7-node cluster. So separately they are managing. Coming to the slave machines, we pretty know that slave data node and task tracker are the daemons or services related to the slave machine. Okay, up to that we are very clear. Now the point is how they are communicating is most important point, guys. In what way they are communicating and how they are supporting us is the $1 million question. For that, what we are doing is see the HDFS orientation. As of now, if I am talking about the storage, I know that name node, data node, secondary name node are belonging to one category. If I am talking about the map reduce, our job tracker, task tracker belonging to the other category. This is the storage relevancy and this is the process relevancy, the programmatical aspect. Now, let us try to understand this way. All the black colored lines are there. Na? So secondary name node, of course, belongs to HDFS. Name node, of course, belongs to HDFS. Don't confuse that this job tracker. Of course, if you are installing entire Hadoop in your single machine, then obviously HDFS should have the communication with this machine. Okay, that means we are pretty clear na name node. But if you observe this kind of thing, data node may not directly involved in the HDFS, but through the name node. Okay, because as a name node gives the instructions to the data node follows the instructions given by the name node. Okay, data node is not having any separate agenda or separate aspects. And of course, secondary name node pretty clear, not much problem. Secondary name node is a backup copy of the name node. So that is understand. And coming to the map reduce, of course, job tracker, guys. So because in a single machine, name node and job tracker are together, that is the reason this map reduce is verifying this in this machine only. Where do I find out this job tracker? Because in fact, your entire map reduce aspects are revolving around the job tracker only. Okay, na? Right. And of course, individual job tracker is there, then no, there is no problem in case of the cluster. But whereas if you are installing Hadoop components in your machine, then all the components, all master and slave are residing in a single machine. In that case, this has to communicate the appropriate status information with respect to this job tracker. That is understood. Now, if you observe the blue colored line is the communication between job tracker and task tracker. What kind of the communication? Very simple. Job tracker assign the task to the task tracker. Okay, and exclusive discussion is there, friends, related to map reduce. Tomorrow is the base for the map reduce understanding. Based on that particular map reduce understanding, storage logic understanding is pretty simple. What you can see is just I am having the replication as 3 and Hadoop is storing that particular data in data node by the instructions of the name node and secondary name node is the backup copy. If you are knowing this much, you know HDFS, but MapReduce hardly what we have seen processing, parallel and simple programming model, but we have not yet discussed what are all the internals of that MapReduce. Okay, once you start understanding that parallelism and job scheduling, task monitoring, up to the level of the Spark, the same terminology, the same process continues, friends. That's what I'm saying. Tomorrow's topic, MapReduce, will hunt you until your PySpark or Spark orientation. Okay, not only in your Hadoop tools. Of course, Hadoop, we are having MapReduce 1 and MapReduce 2 or add. And on top of this particular understanding, you can build the Spark architecture also. Because more or less the terms and terminologies, only the thing is this Hadoop is the disk-based storage and our Spark is in-memory storage and all the other things like cluster management, resource sharing, and all these resiliency, all the things are common. So the fundamental identification of your parallel programming is really helping you to leverage up to the Spark orientation, right? Okay. So in this particular case, guys, very in a high level view, we are seeing job tracker is giving instructions to the task tracker so as to perform some kind of the task, and task tracker periodically update the information to the job tracker. It is going to update the information to the job tracker. Information update in the sense how much job has been completed. Is there any failure is there? And what exactly the status? All these kind of information periodically should be given by the task tracker to the job tracker. Okay, that is what how you can see the daemons. Of course, only one point we observed is um, after identification of the masters and slaves, there is a strict communication between the master daemon and as well as the slave daemon that we have seen. Now, I'm introducing this architecture, friends, actually. So let me copy this because we have discussed some more aspects. Now you have a look on this, guys. This is a typical architecture where you can see, because as we are talking about name node is a central point, and of course it is prone to the single point failure. Uh, and moreover, this particular name node maintains the metadata. And if I want to write the data or if I want to read the data, then I have to contact the name. Then we'll try to understand in what way these metadata operations are taking place in terms of the name node. So it's pretty simple, guys. The metadata operations maybe the file name and file size information and location. Okay, all these things are nothing but the metadata info. And metadata operations in the sense maybe accessing of the file or copying a file from local file system to HDFS, some kind of operations I can perform. Now, you know, guys, once this particular name node is equipped with metadata, whatever the metadata I'm having, it is going to support the secondary name node also, because your secondary name node is something which is taking the backup of that particular name node. At times, you know, as I said, there is a single point of failure. So as to, if any problem is there for the name node, okay, we can take the backup from the secondary name node. So that is understood. Now, suppose if I want to perform the reading operation, let me try to give the reading first, a reading operation. Now what I can do is just I am specifying like this, Hadoop fs -cat hdfs1 is file name. Is a reading operation, guys, where obviously the appropriate metadata is available. The metadata contains the file name, location, size. Assume that file name is hdfs1, location is data node 1, size of that file is assume that 500 MB. Now, likewise, another file is there because the replication factor is 3. No? Replication definitely at any point of time, 3 copies would be there for this. And somewhere HDFS1, maybe I'm having in data node 3, again 500 MB. Okay, now tell me, friends, while performing the reading operation, this particular client need to access all the three locations or one location is enough? Question is pretty simple. While performing the read operation, whether cluster need to access all the three replications or one is enough. Okay, let me pick a person. Akhil?
Yes, yes, Pawan.
Yeah, Akhil, go ahead.
Client can access from name node,
Hmm.
Pawan, because name node have the all the metadata, right?
Okay. Mhm. So you are attempting the read operation. Very good. You should contact the name node. Name node is having the metadata of file name and location. Perfect. That is fine, Akhil. Now the question is whether the reading process should touch base all the three locations or one is enough. We are talking about the reading. We are talking about the reading. Actually, our file one is available in three locations. One, two, three, like that. And whether I need one copy is enough or three I should read.
No, we can read one of one thing.
Only one. That's it. Perfect. Okay, very good. See, guys, very simple narration. Maybe initially we may observe that three replications means we have to go through three. Not required, guys. Actually, you are reading in the sense I want to get the content of this file one. Okay, I want to get the content of this file one. Now, what I'm trying to do is I want to perform some cat operation, which we pretty know that to read the contents of the file. Only whatever the nearest location, okay, just whatever the available, whichever the available location. From that, the file has been fetched and it is hand over to the client. Okay, so that is what how you can see this diagram. This is probably the client machine. Client means user only. So user gives some command and he is going to perform some kind of the activity and accordingly he can fetch. So one point is very simple. No matter how many data nodes or how many replications I'm having, but reading operation is only requiring one copy of the data. One copy of the data. Now, one more point I am asking here, guys. Let me put this way. What I am doing here is Hadoop fs hyphen copy from local, lfs1 to hdfs2. Of course, this is the write operation. This is the write operation. Now this write should communicate with the name node. Okay. Now tell me friends, whether this write operation should performed on three locations or only one location. I'll put I'll pick up one more guy. Okay, hold. Akhil, well done. Sahu, what is your thought process on this?
Yes, it's three locations because
Three
we are
locations. Why it is so?
writing the data.
We are writing the data frame. Just to have a look on this, guys. Writing the data, no matter whether we are getting the data from LFS or getting directly into HDFS, that is not the important point. The important point is whenever you are going to write some data into the cluster, okay, this name node, okay, see the metadata. Okay, hope all you are with me, guys. See the metadata. Assume that this file 2 is requiring 1 GB of the data. And now you see name node is having the metadata. No? So this particular metadata contains the, because status, every data node should give the status information, no? Whatever the locations it is using and whether it is alive or not, all those kind of the conventions. So what it does is Just it is making use of, okay, the name node, see which are all the free locations of these particular data nodes, and it is going to instruct the cluster. You should write file to in all the locations. Okay, this is the way how the Hadoop cluster or this name node helps us so as to write the data into three locations. And in case of the reading, guys, we need not worry about the three locations and accessing of all those particular three. Rather, what you can do is you can simply make use of the convention. Okay, so directly any location is okay, and it is enough to get the data from that particular location. But if writing is different, guys. Every time if you attempt a process of writing, definitely the cluster should make sure that there should be three different locations for the same file, as the default replication factor of this Hadoop distributed file system is 3. That is the reason. And of course, you may ask me this question: can we change the replication factor? Can we change the replication factor from 3 to 5 or 3 to 2, something like that? Yes, we can. Because if many users are there and that particular file is most important thing, and we are using some 50 node cluster, assume that we are using 50 node cluster, then in that case you can raise the replication spans, maybe for the sake of reliability, and maybe many members are trying to access the data. But sometimes, we are using only 3 node cluster, assume that 3 node cluster. So in that case, I can reduce that thing to 2. The replication factor can be 2. I'll show you that, guys. How do we increase the replication factor and how do we decrease the replication factor as per the requirement? Okay. Now I'll stop here, guys. But before taking the break, uh, just let me give you one more insight. So, how the appropriate activities are taking place in case of the Hadoop architecture, and just before leaving, just to see this architecture, and probably tomorrow I'll open up some kind of the discussion related to this thing. But now what I'm doing here is simply I'm giving some kind of the insight. Okay, only some kind of insight I'm giving. Let me get that presentation for you so that you can see that. And however, in the tomorrow session, just will have a discussion on that. I will look on this, guys. So just I have consolidated all the things, and I have given some kind of the notes also. So probably you can proceed with this particular task. Okay, in the tomorrow session, maybe you need to talk about this particular thing. Okay, all the consolidations. And before the break, let me give you the key takeaways, what we have seen so far. The very first thing is, again, we have seen the Hadoop services. And coming to the second one, we have discussed about big data versus Hadoop. And then we have seen the distributed file system. And then what do you mean by structured and as well as unstructured data? Those things we have seen. And related to the WinSCP usage, how do I get the information from local machine to local file system of the cluster by providing the host name, username, password details. And next we have seen some kind of Hue login portal, Hue portal, where this local file system is related to home. Home means local file system in Hadoop, whereas your distributed file system always starts with this thing user. This is the HDFS. You can clearly observe the distinction, guys. If you see the home, that is a local file system. If you see the user, that is a Hadoop distributed file system. And from this directly, what you can do is upload the files, and you can delete the file, and you can recover also, recover the file. Okay, these things we have seen, and latest we have seen some Hadoop master slave arrangement, and now we have seen Hadoop architecture. Okay, now after the break, just I will showcase some other commands. Okay, as I said, now the replication factor, all these things. And if still time permits, then we'll go back and see this diagram is there, no, architecture diagram, which is very important. These things I will try to cover, or Hadoop internals. Okay, that's all, guys. We'll have a break on this. Okay, so now just you let me see if any doubts were there in the chat. Uh, Otherwise, we're eligible to take the break. Okay, as was not asking, in case of continuous data flow, how does Hadoop capture his continually coming data? There is no Hadoop streaming, guys. Okay, Hadoop streaming is not there. Only you have to use the Spark, or else there are certain cases are there. Flume also we can use, but it's not a strictly real-time streaming, guys. Actually, that is a problem with Hadoop. Actually, so Hadoop is having some limitations. And of course, with the help of the Spark streaming and all, we can perform that. And Hadoop never supports real-time analytics. Okay, only it is for the sake of distributed storage and as well as the processing of the data. Any other doubts? Yeah, these are all your contributions. Once we came back from the break, I'll go through each and everything because I love to hear from you guys. So definitely after this, after reading of all these contributions, we'll talk the remaining comments, and we'll work upon Hadoop architecture. Okay. So that's all, guys. Let me switch on the timer. Uh, mm, so after the break, remaining things. So, friends, I'm back. Please confirm your availability so that we can.
Yes, sir.
Yeah, thank you, Akhil.
Yes, sir.
Yeah, right. So, just before the break, friends, we have seen some of the important aspects uh, where I can observe the placements of the services and how these particular services are really helping us, okay, to work with reading and as well as the writing operations. Okay. And the architectural arrangements also we have seen in a high level view and how master slave are taking place and how these kind of things are working. And some more elaborated image I have given to you. So I have parked this particular discussion. So just you can have a look on this and probably if time permits today only we'll see. Otherwise we'll talk tomorrow, right? Okay. Now, I want to introduce some more aspects related to the command set. We are slowly moving ahead in the understanding of the Hadoop architecture and all. What we are doing here is, guys, let me start with our cluster. So this particular cluster, hmm, I have opened. Let me, okay, 1 minute, guys. Okay, so yes, this cluster I'm making use for the command orientation. All as of now, web shell is enough for us with the web shell, and it is a for any Hadoop based kind of aspects. Web shell is most preferable mode. Okay. So now certain aspects I want to showcase here, guys. Let me clear the screen. Um, so far, with respect to this command orientation, we observed the loading of the data and processing all these kind of things. So let us have some more things. We are having these kind of the files, Hadoop ls. So what we are doing is just let me give you this command. So HDFS file system check. Okay, and HDFS 3. Now, if I'm having any, if I want to get some kind of the information, okay, related to my file, whatever I'm having. So I want to know how this particular file is located and um, some kind of the configuration or some kind of the architecture I want to understand. Now you see, friends, here at the moment I am giving this file system check command on top of this particular file. It is connecting to the name node. You can clearly see that you can connect just this particular cluster is connecting to the name node, and it is giving the where we are working actually. Okay, through this kind of the uh, interface, and then it is giving some file system check. The path of this particular file is this thing user. As I said earlier, user if I am seeing, then obviously that is belonging to the Hadoop distributed file system, your root, big data mined one, your root, and the actual file name. Okay. Now, if you are referencing the status, whether this particular file is available or not, the status of the data nodes actually. At times, friends, there may be a possibility of dead nodes or unavailable data nodes. So, in a way, I want to access that kind of information also. Then you can see how many data nodes are there here, 5. Remaining 2 are belongs to the name node and number of racks within that particular rack. Actually, if you are familiar with the redundant array of inexpensive disk space, RAID architecture is different actually. So the RAID is a kind of architecture where it is providing some kind of the slots so as to store the data. Okay. Now the size of the file and how many files we are having, total blocks. Friends, most importantly, Hadoop black storage is a very important topic, friends. Along with the Hadoop architecture and MapReduce, what I will do is tomorrow we'll talk about the block storage. Because if you want to store any file into the Hadoop distributed file system, then definitely it should split into the blocks. And Hadoop fundamentally follows the block storage. Okay, that information and how many blocks were there, and minimal replicated blocks. At least one block should be there, and default replication factor is 3. And average replication factor across all the files is 3 only. That's what it is, not showing any other value. Okay, so likewise, all these particular details, okay, where you can find out with the help of the file system check. And basic points we need to observe here is your file system check gives the understanding of how we are connecting your data, how we are connecting with your name node related to the interface, and thereafter how many data nodes, that information, okay, is there. All these kind of things. Apart from that, most importantly, the blocks, how many blocks were there, and how many replication, what is the default replication, what is the average replication. All these kind of the details can be observed while talking about the FSCK command. Okay, and this is one thing which is pretty useful if you want to know about the status and health of that particular data. Okay, and coming to the other option, guys, once this is over, so generally, if I am referencing this Hadoop FS hyphen ls, just you can see here, for all the kind of the things, we are having the replication factor as 3. Okay, we are having the replication factor as 3. Of course, I changed this one, friends, while preparing for your session. Just I have changed this thing. Don't mind. So now observe this particular thing: abc.csv, dataset.csv. For all these kind of the data or whatever the file I'm having, the replication factor is 3. So sometimes I don't want to keep this abc.csv as 3. Okay, only I want to give some replication factor as 2. It is enough for me to replicate that particular file 2 times only. Further, guys, just you see here, as I said, every Hadoop command start with Hadoop word, but this time I am using HDFS actually. Okay, so HDFS, okay, just if you are making use of that thing. So your HDFS is the initial kind of the command. Okay, so where rather than using that Hadoop, just I'm using the Hadoop distributed file system directly and distributed file system. HDFS, DFS. Now what I want to do is I want to set the replication factor hyphen R. Okay, hyphen R. Just I want to mention the number of replications I want. Now abc.csv, I want to replicate only 2 times. Now just to give this thing. So double H we have not given. No? All right. Okay, it is saying that. Now you see that HDFS hyphen HDFS DFS, that means Hadoop distributed file system DFS command, because there is a pretty clear distinction, guys. Hadoop FS hyphen ls, something like that we are using, where there is no change, or there is no, we are not dealing with any internals of the Hadoop. But whereas at times, if you want to perform some kind of the activities related to your file system replication chain, for those kind of the conventions, you can make use of this set replication. Now let us confirm that Hadoop fs-ls. So now if you observe this particular thing, okay, so automatically I need to see only the 2 replication for abc.csv. Okay, because it is reflecting in this particular replication. So obviously my abc.csv is getting into 2 replications only. So it is typical understanding of the Hadoop replications, because always it is not preferable, especially if your cluster is more valuable and precise, and if you want to maintain your cluster in a perfect way, then you can make use of this replication. Okay. Now getting back the appropriate replication. So like this HDFS, DFS, hyphen set replication, hyphen replication R3. And what is my earlier file? Maybe HDFS1, I have changed from 3 to 2. Now I want to go with the 3 only. Okay, so just to see here. And immediately it is giving that replication 3 set to HDFS1. Now I can easily say that just Hadoop FS-ls, and practically I can see that 3. Now it is HDFS is now becoming 3. Okay, so let me record this. So maybe while preparing, you should not feel any difficulty. But before that, let me share the screen, guys. Okay, over the period, if I'm completing 10 commands, then all these 10 commands, again, you have to go back and see the recording so as to avoid that thing. Just whatever the things we are seeing now, commands. In the earlier, before break, what we have done, WinSCP2 LFS data loading, this we have seen. And second command we observed is with the Q login portal, we have directly done the data loading to HDFS. And as a byproduct, we have seen file browser. And this particular file browser allowing us to delete the data and view the trash and complete deletion, permanent deletion also possible. Okay, these things were seen. Now we observed some other command, file system check. So how I need to check is now just for this, rather than using Hadoop, I am using HDFS file system check, and I am giving the file name. Okay, then obviously what it is giving is the name node info, name node. Okay, just you are connecting with certain IP, and it is talking about the health of data nodes, and it is giving number of data nodes as whatever the number of data nodes I'm having, some 5 data nodes I'm having. Along with that, it is saying some replication factor, the default replication factor, just to notify that. And it has given some average replication factor also. This has given like some float value 3.0 like that. So initially, this particular command helping us so as to observe, so as to identify how the how we are connecting with the name node and what is the health of the data node and how many what is the replication factor, all these things. Coming to the next command, this is to manually set the replication factor. Okay, to manually set the replication factor, because we have very clear that the default replication factor is 3. Now I want to, for especially HDFS1, I want to set the replication as 2. Rather than 3, I want to set that as 2. Now further, have a look on this, friends. As I said earlier, we should start with HDFS, and this is a DFS command, and set replication number to the file name. Okay, then automatically, if I want to check that Hadoop FS-ls, then you can see the replication factor as 2 for HDFS1. Now you can easily get back that to set to 3. Simple, same way. HDFS DFS set replication -R3 replication, and as well as HDFS1. Now, if you want to see whether it got reflected or not, simple -ls. Then obviously you can observe 3 HDFS. Okay, so this is the way how you can set the replication and as per your requirement. Maybe if you want to increase the replication, that is also possible. That is your wish. Instead of 2 or something, just you can give 5. Obviously, those replications can be available, because as I am having the data nodes, 5 data nodes. So data node 1, 2, up to 5. Okay, just the 5 will be distributed. Now a question for you guys. Suppose I want to set the replication as 10, but I'm having only 5 data nodes. What is your thought process on this? Whether it is yellows or not? whether it allows or not. Okay, let us give a try because we are having the machine in front of us. Just will try to give the 10, but you need to give if it is allowing means why it is allowing. That also you need to give to me. Okay, let me first see whether it is going to allow or not. Okay, so HDFS. First, let me see which are all the files available. So I'm having some files with me. Mm, this sales one I want to change because there is a group of people working on that HDFS DFS hyphen set replication hyphen R 10 sales one. Okay, without any problem, it has set the replication, but we are having only 5 data. What is the logic behind things? What is the logic behind it? Let me pick up a person so that. So, Bala, any thoughts? Because one thing is yeah. Hi Bala, how are you? Yeah. See, hope you got the point, Bala, because we are pretty clear that we are having only 5 data nodes as per our cluster. Okay, but we are trying to give this replication 10. Without warning, Hadoop could able to do this replication factor as 10. How come? What could be the logic behind that? Is there any ideas popping up into your mind, or what is your thought process? You see, guys, here only 7 hosts, and that two are dedicated for name node, and only 5 nodes were having as a kind of the data node. Okay, right. Is there any point coming into the mind, or what is the idea behind that? Why it is LOE? Okay, the answer is simple, guys. Because if you are working with some kind of the data nodes, okay. So let me show you this thing, friends. Assume that my sales file is requiring 500 MB, and however, the point comes here is block size. Block size. Assume that as we are using Hadoop tree, this is block size is 256 MB. In 1 and 2, we are having block size as 64 MB, 128 MB, and of course, this also can be resized. Friends. We can make use of that. Okay, so absolutely that is fine. Maybe 128 or 256, whatever. Assume that our current block size is 256. Now the point is, be with me, guys. Very very important topic. I thought of covering this tomorrow, but however, the point is valid here. Just I asked Bala. Again, you may not aware of this thing. No? That's what I am raising this thing. So name node, what it does is it got the request of 500 MB file storage, that too sales one. It should allocate 3 locations. I'll come to the 10 points later, 10 locations, but initially my requirement is 3 locations default. Assume that now data node 1, data node 2, data node 3, 4, 5. Okay, 5 data nodes are available. Maybe it's selected data node 1, 3, 5 so as to store the data. Now the point is, friends, actual block size, because this data node 1, though it is 1 terabyte, its block size is 256 MB. Okay, across all the data nodes, we're having the block size as 256 MB. What we mean by block size is uh, very simple point, friends. Here, I want to store 500 MB. This entire file is not going to fit with a single block because this single block holds only 256 MB. Now tell me, friends, to store 500 MB, how many blocks do I need?
2 blocks.
2 blocks. Perfect. 2 blocks. That means this 500 MB, 2 blocks. Replications are 3. Total how many blocks? 6 blocks. Okay, this is nothing but your replication factor. Now observe here, guys. Now, as per the analogy, name node selects data node 1, 3, and 5 so as to store the data. Now it has to allocate 2 blocks, 256 MB, 256 MB, sales 1. In data node 3 also, it is going to allocate the same 2 blocks. And data node 5 also MB. Now the point is, guys, suppose name node want to access this particular sales 1. Okay, how it is going to maintain the metadata is just observe here, guys. Okay, maybe this is block A, block B, block C, D, logical names to understand the concept easily. Block A. Now, how it stores is the file name in data node 1, which are all the blocks A, comma B. Second one, sales 1, data node 3, C, comma D. Sales 1, 5, data node 5, E, comma F. Now, at the moment, any user, okay, want to access sales 1, want to read a sales 1, then from either of these particular data nodes, okay, maybe randomly select data node 3, and as it is knowing C and D blocks, so C plus D is equal to sales 1, 5. Like that it is going to perform. So this is what you call the block storage. This is what you call the block storage. Maybe you are having some doubt, friends, here. Maybe you are having some doubt. 256, 256, 512 MB, but our requirement is 500 MB. You are right. Fragmentation, memory wastage is there. Okay, memory wastage is there definitely. Like if I want to store 550 MB file, how many blocks do I need, friends? 3 blocks. 256, 256, 256. Of course, these uh, these are all fulfilled. For additional the 38 bytes also, I have to allocate 256. That problem is there, friends. That we cannot do anything because my moreover, one more important point I want to ask here. Tell me, friends, whether small block size is good or bigger one is better. I mean to say, suppose I am having 500 MB data, whether it is better to store 64 MB or within the 256 MB. Friends, how do you analyze that data? If you are going with the small block size, justify. Small means why. If you are going with the bigger block size, why? Okay, so don't worry, no problem. You need not give the answer today. Maybe tomorrow you can take this as a task. So the simple point here I want to explain to you is Hadoop strictly follows the block storage. Block storage is something like there should be some kind of a default block size, how we are having the replication factor. That especially while talking about the Hadoop 3, we are taking the 256 MB as the default block size. So in that particular case, whenever there is a requirement of storing this 500 MB file, then definitely I need 2 blocks. So obviously the name node maintenance maintains the corresponding file in 3 replications and 3 data nodes. Just it is going to perform the activity of that thing. Now the question remains same. Na? As I said, HDFS. Okay, as I said, HDFS, DFS, set replication, R, 10, sales one. As I said, is a 500 MB file. Uh, replication as 10, and two blocks are enough. Two blocks are required 10. How many total blocks are required, friends? 20 blocks. 20 blocks. But I am only having data node 1, data node 2, 3, 4, 5. Now observe here, guys, it doesn't mean that I need to use the data node 1 only one time. There is no rule then like that. So first it will distribute these 5 blocks. Okay, because 5 data nodes are there now. So just we are having A and as well as the B block. So as to store sales 1. Similarly, in data node 4, I'm having P and as well as Q block for sales 1. And for data node 2, I'm having X and Y block for sales 1. And for data node 5, I'm having C and D block for sales 1 5. And for data node 3, I'm having uh, E and as well as the F block, sales 1. Similarly, in the same data node 1, maybe it is having some Y, Z block. Y already there, no? Y1, something like that. This is also sales 1. Okay, because the block size must be there, no? Block size. Now in data node 2, some other block. Assume that X1 block, Y1 block. Y1 is already there, no? Y2 block, something like E1, F1. Here P1, Q1. Here C1, D1. Now see the final representation with the name node related to the sales 1 file in terms of data node 1, 2, 3, 4, and 5. Because our replication is 10, replication is 10, 10 different locations I should store the data. Now coming to the data node 1, how it is managing its block sizes. So it is managing, the first block is A, B, we are having sales 1. Okay, so as to fetch that particular data, I should go to this one. Or else in Y1 and Z block also, I'm having the sales 1 file. Similarly, in data node 2, okay, data node 2, how it is managing the sales 1 file is, I'm having X and Y blocks, and some other block is X1, Y2 block. And similarly, in data node 3, okay, just how it is managing is E, F block, and as well as E1, F1. Together, I can get these things. Either I can use the EF block or even F1. Now coming to the data node 4, PQ. Na? So just it is managing the block of PQ or else P1, Q1. And data node 5, CD. So just I am making use of this C block and D block, C1 or D1. Okay. So while writing, name node should keep track of all these kind of things. That means in the same data node, I can able to replicate the appropriate file multiple times. Okay. So because the data node again, maybe terabytes I'm having or picobytes or sometimes zettabytes also. There is no limitation for the data node. So if I'm having only 5 data nodes, 5 node cluster, in that particular case, definitely in the same data node, Hadoop replicates the appropriate blocks information multiple times. That is the analogy, friends. That is the analogy. Now tell me one point. While performing the reading operation, okay, as name node is having all the 10 blocks information, okay, yes, only one block is enough. Maybe I can access that one with data node 2 of XY block. or else with respect to X1, Y2 block, or else due to some reason data node 5 is not operatable. Absolutely fine, no problem. I can go with either of the other data nodes and I can pick up as I'm storing 10 different locations. Okay, so this is the understanding how your blocks are maintained with respect to the Hadoop file system. That's most important thing, guys, because many members only there should be some correlation between the block size. The important point here is you need to observe the block size and a replication factor, and then file size, number of data nodes. Because these four parameters are required. So based on these four parameters only, name node decides how many data nodes should be allocated likewise. So assume that here block size is 256 MB. Okay, and replication factor is 3. File size maybe 500 MB. Number of data nodes as per our cluster 5. And we have seen some example related to these categories or these parameters. Okay, so initially maybe you are having some confusion, guys, but again, you should work it out. Pretty simple concept only. But still, if any ambiguity is there, no problem. So just we'll come back to this topic again in the map reviews. Don't worry. But before that, I have given one more question actually. Whether the replication factor less is better or more is better. Okay, it's not the uh, analysis part, friends, and you have to go and see the Apache website, and there directly we may not get the answer, and we have to study some kind of the blocks are also whether small block size is good or bigger one is better. Okay, so especially in heavy data management and while using the certain kind of the input data items, and I want to perform some kind of activities. So in that particular case, we should be very cautious about this kind of the convention. Now that is the reason why our cluster is happy to allocate the appropriate number of the replications, um, though we are not having enough sizes, okay, enough block sizes. Okay, so now you see 10 different slots per. We are not going into the danger. Okay, so simply we'll change this thing HDFS DFS set replication hyphen R. Now I want to make use of free. What is my file name, guys? Sales one. Okay, so just you can make use of this convention. And again, if you go back and verify, it will come back to the normal thing. Okay, never feel that. And even one more thing, friends, even if you are working with your laptop also, after installation of the Hadoop, but still, your replication factor is supportive. Replication factor is 3, but logically that is wrong because in your same machine, if you are storing 3 times also, if any problem is there for that data node, then it is not logical. Okay, so you are mentioning that the replication factor is 3 in your machine. Just only one machine is there, and if something happened to that machine, though I am mentioning 3 or 10, it's logically valid, but physically we won't get those many locations so as to access the files. That is the understanding, friends, actually. So that means if you are installing a Hadoop and if you are manually setting the replication free, I'm saying that there is no use because if something happened to that machine, we are not going to recover that block or information. But whereas if you are maintaining your machine as master and some other two Bala machine and Asru and Srinidhi, these machines we are making as data nodes or task tracker slave kind of the machine, then in that case, definitely how many data nodes we are having and those many replications you can put, or even more also you can put, provided at least 3 to 4 machines if you are connecting with your master, and you're always free to set the higher replication factors also. Okay, so this is the point, friends. And one more thing, Like there are certain aspects where I want to maintain my separate directory because at the moment I'm giving this Hadoop FS-LS, I'm seeing everything in my directories. Like I mean, the open directory, root directory, ABC, dataset, HDFS1, HDFS3, one, sales one, stock one. I don't want to maintain as a single catalog. And of course, okay, similar to your Linux, how we are doing, pretty simple, guys. Just I am making use of Hadoop FS. Just I am creating one directory. Assume that I am working on some data science uh, project. Maybe the members who are having the data science project allocation, this directory only can be given to them rather than accessing all the things. Okay. So now you see, I should see DS folder also. Okay. This just now we have created and it is showing to us. Now let us see how I can copy from local file system and how I can copy from HDFS to HDFS. That is also possible. So now at the moment I am seeing some local file system. Let me clear this, guys. And my local file system is having many kind of the files. Now what I want to do is just I want to get Hadoop FS hyphen copy from local. So just to get the local file information, there is a sales data, na? Sales dot CSV. Now I want to copy this particular thing to my data science folder. Okay. Now let me show you this thing, friends. If I'm not giving any name, okay, there is one advantage. It gives simply the name of the source file. Okay, whatever the source file, because practically I'm not giving any file. Let us see. Okay, so just I'm copying a file into the data science folder. Now observe here, ss-ls. This time I don't want to see all the things. Just I am mentioning my own file, my own directory. Only now see, only it is showing this particular file, and that too, this particular file name, though I have not given, but still it is making use of the source file name. Okay, there is one convention, friends. Rather, I can do like this also. Hadoop fs hyphen copy from local, and another file I want to copy is some stock market analysis data. And this time also I want to make use of the data science folder, and I want to give my own name, top, like that. I don't want to give any extensions or something like that. Okay, so just now you see, this time if I am displaying uh, ds slash, obviously you will be getting the convention, like So earlier, if you are not giving means it is substituting the local file system sales.csv into the HDFS file name. Okay, if you are leaving it, at times also, if you are not mentioning the target file name, obviously it is going to do that. Second thing is, you need not always leave the file name, and you can give your old file name also, provided you can avoid the extension or you can provide that because that is the reason it is supporting every file. No matter. And I will show you some other information like Wikipedia data is there actually. So there they maintain all some statistics information related to that. One large file would be there, and there I want to download that. And again, with the help of the Windows CP, I want to load that file into Hadoop distributed file system. All the things we'll see, guys, because sometimes we may be getting the files in the .gz format. Okay, so which is a typical RAR file or zip file in our Windows platform. Whereas the gz is a kind of zip file in case of the Linux environment. So how do I make use of that thing and how I can elaborate that particular file? Okay, so definitely we'll see all these kind of the works. But now what we are doing is we are into this import and export process. Maybe I want to specify my imports or exports related to these kind of the conventions. I can do that. Now, what I'm doing here is, guys, just let us see fscat. Now, explicitly you have to mention your file name, and now you can give this sales.csv. Now, see, one bigger appearance would be there, and it is showing us the information. Always, guys, one important point. once you confirm your file, and this is okay. But whereas if I am giving some the same file name, some kind of the stock data, okay, sometimes every entire screen will be populated, something like that. Okay, it is taking some time, and this is okay. This is in MBs only. But sometimes, even some GB data also we are going to store, and the GB in zip format. Okay, so it is always preferable to, for the sake of viewing the file, better you go back and refresh this because DS is not reflected here, our DS folder. So that I am refreshing this. It is taking some time. And from this View Login portal, it is always better to view the contents because see the thing is just to click on this. Though the file is bigger, okay, no problem. It is split the file and page wise so that you can see friends actually. So this is the a benefit of using the Q login portal. Of course, if you are okay to use this command prompt and all, that is fine. But sometimes what happens is I'll show in the tomorrow's example, heavy files would be there. Sometimes gigabytes, all those things. 2 to 3 minutes we have to wait. Okay, so as to complete all the rows, and it is presenting all in front of window, all these things. Further, what you can do is just simply go back to your Q login portal, and just you can select whatever the file you want, whatever the directory. Within that, simply you need not wait, friends. Actually, just as this is a GUI based kind of thing, no rolling out or roll up kind of activities. Directly, you can view the appropriate content. Okay. So this is how you can observe the storage logic. This is fine. So just I am creating the folder, and with respect to that particular folder, I can able to load the data. If I am not giving the name of the source file, obviously the same name will be given in the destination. If I am giving also, I can give another name. There is absolutely fine. There is no problem with that. Now, I want to delete some kind of the files, friends, especially in the, as I said, na, so maybe in case of the Hadoop distributed file system, I can directly delete. First option already we have seen. Okay, maybe I can go to the file browser. Okay, within that file browser, I can see all my files and all the directories. And I select, and you can delete that information. But whereas if you see this thing, and as well as you can move to trash, yes. Okay. Now in trash you can find out that. In trash you can find out that. But again, if you are moving to this thing, and if you are providing Hadoop FS-ls, now you observe this how it is showing. The data science folder probably won't be there. Okay. Reason is simple. Just we have deleted that now. Okay. Now the folder is not there. Again, I can go back, move to the trash, and restore. Immediately it is going back and verifying. Okay, refresh, and then if you give the same command again, it gives the DS. One step that is, and that is a simple process. But manually, or maybe for all the users, we may not get the GUI. The danger with the View login portal is left and right if you are using, and if you are uploading your own files also, there may be a big threat for our security files. Okay, probably the admin, Hadoop admin won't allow us to play around with View login portal. Then definitely we have to see the alternate. So that alternate is something like this. Hadoop. So FS, just this time, I want to see the contents of the DB. DE already I have created. So some files were there. Now what I'm doing here is, uh, after making use of this thing, I want to remove that directory actually. I want to permanently remove that particular directory. Now what I can do is there is a simple command, remove recursively. If I'm giving only remove directory or something like that, see, remove directory I can give, and I can specify this particular directory name, rmdir. Okay, directory is not empty. First, I should go and delete that particular file. Then only I can able to delete. RM directory is valid only. But if it is, if the directory is containing the files, I cannot directly delete that. So the solution for this is just you can make use of Hadoop FS. I can remove directory recursively. This is probably the simple approach rather than going back and verifying that particular convention. Now you see guys here, it is something it is saying deprecated. Now many a times, even while working with Python and even some kind of the Java functionalities also, some of the approaches or some of the files or some of the commands may be deprecated. That means are still under consideration, or maybe they are using some kind of the extension logic. For all those kind of the conventions, one can manage the functionality. So don't worry, it is just a warning kind of thing. What it has done, a file has been moved from this thing to trash. Okay, logically this is thing. Now if you are going back and you see the trash, it should be there. DE must be there. Okay, so because we have done some kind of the operation there and it is taking some time to establish the connection and all. So now DE is there. Okay. Logically, I can delete frames. I cannot mention that. And moreover, if you want to get back this particular thing, as usual, select and restore. Or else, if you want to permanently delete that, you can go with the trash, whatever the method you want. Okay. So just this time, I want to restore the contents. Okay. And now, as usual, again, I can use the RMR or whatever the way. So DE available. Just now we have restored that. There is no harm to our DE folder. But logically, you can delete this RMR and it will go to the trash. And there Hadoop admin will decide things. Because as I said, na, as a developer, we may not have the complete control over the HDFS file system. And in that case, admin will confirm with us and with our manager. This guy, Dr. Roma, is going to delete this sales or stock data, can I remove or can I restore? Even sometimes we, we don't know also. Okay, so in that case, if manager is okay, then definitely that guy can delete it. That is a maintenance operation, friends. Okay, so as to one more recheck actually, that should be enough. So because as we are always working with heavy data, and if we suddenly delete some of the files without clarification, then it is going to affect the entire project. So that is the idea behind that. And moreover, there is a clear distinction, friends. That's what I am waiting for your doubt. Like moving is not allowed by the distributed file system. Suppose from the HDFS, if I want to move a file from HDFS to local file system, it never allowed us. But it is allowing us to delete the file completely. So observe the distinction between those 2 points, friends. Intentionally, what I am doing is I don't want to continue with the file so that I am completely dropping that file or deleting the file. But whereas moving is different, friends. Moving in the sense I don't want to lose that file, but I want to place that file in the local file system. But Hadoop won't allow that convention, guys, because there is no concept of editing or something like that. So we should be very cautious while performing these kind of activities. Okay. And one more thing, maybe if I want to delete some kind of the files, just to have seen the directory deletion with the help of RMR. But whereas sometimes I don't want to keep this HDFS one or something. Now you see, let me clear the screen. And again, once more, just let me show you the files which I am having. Now there is a simple command, Hadoop FS, a simple command, rm, remove the file, just you can make use of this HDFS one. In this case also, just it is moved to the trash and all these things. Because as a developer, we are not having complete narration of deletions. Okay. So again, same thing, just you can file browser, okay, with respect to that particular task. Because if I'm doing something in the command prompt, it is taking much time. So I have to consolidate because every time it has to fetch the data. No? That is what it is taking some time. So now let me consolidate all these discussions, whatever we had. So this particular trash, HDFS, now you can empty. Okay, I got the confirmation. Yeah, you can delete that particular thing. Now you see, if you observe, Hadoop FS hyphen ls, then obviously I'll be getting that I won't get that HDFS one. Okay, so that is how you can narrate the deletion process of the directory and as well as the data. Let me record these things in the our OneNote friends, so that while preparing you should not get any confusion. Okay, so just we have seen some of the commands. These particular commands up to replication we have seen. Next thing is we talked about the dir creation. Okay, for that I'm making use of this convention Hadoop FS hyphen mkdir data science. Okay, once this is over, place the file from LFS to HDFS DS folder. Okay, so simple. What I can do is same command Hadoop FS hyphen copy from local sales file, sales one.csv. Only I'm mentioning the ds flash. Okay, what it does means the same name as the top LFS, that is sales one, will be given to HDFS. Okay, HDFS ds slash sales one. Okay, another mode is simple. Just I want to make use of Hadoop FS copy from local. My local file system is stocks data actually. Stocks one.csv I'm having. And what I'm doing here is ds slash stock. That's it. Okay. Then you can even whatever the name you want, you can perform it. This is one more thing. And thereafter to view the contents, which command comes number 6. Okay. The seventh one, to view the contents from the directory. From the directory. Then what should I do? Just you can go Hadoop fs hyphen cat ds slash stock. That's it. Okay, only the difference is rather than leaving the path explicitly, you need to mention that. And one more thing, to remove the directory. First option is I can use this thing actually Hadoop fs hyphen rmdir some ds. But make sure that ds folder must be empty. Empty. Then only I can venture this operation. Otherwise, the best possible way is like this. Okay, though the files are there, if I want to still remove that RMR DS, automatically it is going to remove. And one final command, the ninth one, if I want to remove a file in HDFS files, just to have a look on this. Okay, so how do I do that? Just simply Hadoop fs remove HDFS. That's it. So this is the way how you can refer the appropriate things. Okay. Now coming to the key takeaways, already I have mentioned. After the break, just we have started with the set replication, and we have discussed about the block storage of Hadoop. And thereafter, we have seen some kind of file system check command, and then we have created some directories, working with directories, and a remove directory or file. So these things we have seen. And coming to the tomorrow session, okay, so I'll introduce you the first I'll ask you to talk about that architecture diagram, whatever I have shared with you. Second thing is, guys, map reduce, so which is very interesting and required for all of our whatever the ventures we are going to do in future. Map reduce, and of course, I think this is this itself took some 2 hours and 1.5 to 2 hours, both explanation and as well as the practical submission of the job and all. Okay, that's it, guys. That's all for today and from my end. And if you are having any doubts, sorry guys, today also I could not go through these things. Um, so with this, we have done with this session. Uh, Hope you are clear with the topics. If not, also no problem. Once again, in the next session, just I will be recapping at a summary level so that you can have the look. But my strong suggestion would be just to go through the class shell and as well as this. If any still some doubt persists, go to this recording and view that. And coming to the task orientation, guys, let me place those tasks into the Slack mode. I don't know. Still, some people are not joined Slack. Is there any reservations or something like that? I'm not understanding. But if you are not joining means you won't get any updates from me. Okay, so because I generally prefer rather than flooding the streams and all, just I don't think there is a problem for you to join in the Slack. Okay, so just to think through. Okay, these are all minimum things you can do. And still, if you are not joining, means you are not kids or something. Na? So that is what. Okay, let me see tomorrow, and I'll ask to suppose if any member is not join in the Slack, then is there any specific problem for you? Then we'll talk. Harish, tell me. Any doubts?
Sir, can you share some installation for Hadoop
Yeah,
in this?
sure, Harish. I thought of maybe tomorrow I will give the demonstration of the installation also. One
Okay,
thing,
okay.
friends, actually, yeah. No, because rather than you directly doing, what I can do is, before the starting of this map reduce, friends, I'll show you Hadoop initialization procedure also. Okay. I'm having the document with me, but I want to share some important views so that once I do that, then it becomes easier for you. And still, it takes 3 to 4 hours, guys. Believe me. First time while I'm
Okay, okay.
installing took 9 hours or 8 hours because we have to configure many things. Okay, that is the
Hmm.
reason. But of course, soon we are going to get some access of the cluster. In that case, we need not install anything. But otherwise, we are having another plan also. That virtual machine is there. That virtual machine is a pre-configured kind of thing. First, I'll give you the installation procedure. Follow that. Okay, both one and as well as the two, whatever. So just both the documents I will share with you. Just to venture installation, nothing wrong, na? So no problem. Just you need to install virtual machine, and if something goes wrong, just you remove the virtual machine. That's all. Nothing is going to happen to your Windows operating system. Okay.
Okay.
So yeah, that definitely will do, Harish. Thanks for asking, and thanks for reminding me. Because simply, if I am going and doing these things in cluster, you are getting the points, but hands-on must be there, no? So that is the most important thing. Okay, that's all, guys. Thank you very much. A little overboarding, but uh, abruptly we did not terminate. Okay, just to go through and if possible, have a look on the tasks also based on your availability of the plan. Okay. Thank you. Thank you very much.
Yes. Thank you.
Yeah.
Thank you,
Thank you
sir.
all.